Hi, my name is Mark Riddell. I'm a professor of computer science at Georgia Tech, and I'm glad to be with you giving this talk and to be able to share my thoughts over the last a decade or so about computers, computational creativity, and Ada Lovelace. So a little bit about myself, if you don't know who I am. Once upon a time, I built an AI story generator, and for some strange reason, people decided to give me a PhD for it. Great, happy with that. This talk is not going to be about story generation, but I just kind of want to start by talking a little bit about this first system that you might call a creative system, a story generator that I first built. So my kind of thinking at the time, my work was to treat the story generation process as one of logical theorem proving. So given a premise and a conclusion, what were the transformations in the state that happen in order to transform the premise into the conclusions, right? And so you'd say these axioms of change are the actions of characters, and suddenly you can interpret this kind of logical implicature chart as a story to convert it into natural language. So the idea was you give it some sort of idea of what the initial state of the world is, you give it some sort of idea about how you want the story to end, and then the algorithm fills in everything in the middle. And you got great stories out of it. Except one of the things that always kind of bothered me about the work was I never could draw a clear line and determine where the creativity came from. Was it the algorithm? Did I build something that was truly fundamentally creative? Or was it me as a domain engineer who put together some really complicated, interesting axioms and preconditions and effects on actions that made the system great? And I never could kind of figure out what the answer was. So in 2004, 2005, I started thinking about this, thinking about what it meant for computers to be creative, started writing about these things. At the same time, I started building more creative systems because you can still do great things if you don't know what creativity is, right? So we built cinema generators, we did machine learning for story generation, we built game generators, even started to think about our own theories about computational creativity. But all this is to kind of say that this idea of creativity was taking off in the world. This was really kind of launched in the last few years by neural nets and GANs and visual processing, but also language processing is coming up. And one of the most exciting things that's really kind of happened in the last, well, months really, is OpenAI's system, DALL-E, which came in and was able to demonstrate these really amazing kind of compositions and blends of ideas. So creativity has become this kind of big, hot, exciting sort of topic, and I'm very excited to be able to share everything that's been going on in the world and see all the great things that have been going on. But also, I've had a lot of questions. It's left me with a lot of questions, and I think they're unresolved questions. And I'm a scientist, so I love questions, so I want to share these questions with you. So one of the questions, of course, was, humans, computers, how do we allocate the creativity between the algorithm or the system and the person who designs it or engineers it or initializes it? So nowadays we do a lot of prompt engineering, for example, right? So is the creativity coming from the algorithm or is it coming from the user? That was the problem that kind of vexed me from the very beginning. If we do decide the system is creative, what are the aspects of the algorithm that are responsible for the creativity? Can I point to a module or a piece of code or a model and say, that's where the creativity is, and I can kind of prove it to you? What are the attributes that a creative system should have? What does it even mean for a computational system to be creative? Why do we want systems to be creative? And really even kind of what is creativity, right? I don't know if we know clearly what all these things are. Now, we don't have to have answers to all these things. Let's start with a hard one. What is creativity? Okay, so here's what I think creativity is. I have no fucking idea. Oh shit, am I allowed to say fuck here? I don't know. Oh shit. Okay, moving on. I don't know what creativity is. I don't really have a good idea. Philosophers and psychologists can tell us their thoughts about those things. But, even if I don't know what creativity is and I don't have a good definition for creativity, it doesn't mean we can't still do good work. We've done that with artificial intelligence from the very beginning. But let me do say that I think, in my experiences, both looking at people, working with AI systems, I've kind of come to believe that there are at least 4 factors that need to go into our AI systems if we are going to consider them creative. And I think this also kind of sets a research agenda. Okay, so they're novelty, expectation, learning, and intentionality. So let me take you through these. So the first is novelty. I think novelty is the easy one, right? So novelty just kind of means different from things that we've seen in the past or different from things that have happened in the past. But what I do want to say about novelty is that it is not a sufficient condition for creativity. It is necessary, but it's not sufficient, which does mean that I think creativity does not equate novelty. I think a lot of people kind of have these two ideas closely aligned in their head of creativity and novelty. But I think they're actually kind of different, and they're different in important ways. One of which is that if you get too much novelty, you can result in perceptions of randomness, right? So too much novelty just basically means random. Things become very random. And random, people stop thinking of as being kind of useful. So what is it that can balance us against novelty, against randomness? And one of the things that I think is going to do that for us is expectation. So what do we mean by expectation? Meeting of expectations. So what I really mean is understanding, right? So we have to have some sort of frame of understanding. Our system has to kind of understand the world the same way that we understand the world. Otherwise, we can't make connections to the system, and we can't understand the art or the artifacts that our AI systems are able to produce. Okay, so this can happen in many different ways. I think there's many different levels of expectation we can talk about here. But the basic idea here is that the AI system is able to, through its products, share mental models of semantic concepts that we also share, right? So, and I think we can kind of see this as a really great example from the OpenAI's DALL-E system with one of their examples of, and this is an illustration of a baby daikon radish and a tutu walking a dog. So if we look at these images here, we see, the tutu tends to be on the lower third of the body, right? About where you would expect a waist to be on a human. So what that tells me is it kind of has a similar understanding to the functionality of a tutu that a human does. And I can't believe I'm talking about tutus. But also walking the dog, right? Walking the dog implies a leash, and nothing in this prompt says there should be a leash, but the system kind of also understands that leashes are an important part of the process of walking a dog. So it kind of also shares this semantic understanding of this concept of walking that we have. Now, the leash is also sometimes connected to the tutu, which is not quite right. So there's some error going on in here as well. Now, we can meet expectations. We can also exceed expectations. So level 2 is not only meeting expectations, but intentionally challenging shared mental models. And intentionality is the key word here. So although sometimes we do see the leash attached to a tutu, the system is not trying to challenge our understanding of what it means to walk the dog. And I'm going to come back to this notion of intentionality. It's going to turn out to be very important later on. But let me shift gears to a third aspect of creativity, which I think is very important to both humans and computers, which is learning. So now, what I do believe is that creativity can be learned, also, or at least skills. The skills of creation can be learned, right? We can at least say that. And the learning of creation or the learning of creativity seems to happen in a very regular sort of way. At the very beginning, in phase 1, there's imitation. So we learn to make art by looking at things that we like and replicating those things, imitating those sorts of things. And I have a 7-year-old son, so I can see this happening and playing out in real time. So the other day, my son drew this picture of a cat. Now, the way he figured out how to draw this cat is he watched a video tutorial. Now, more importantly, once you imitate, you can also start to explore your boundaries. You can say, well, I can actually make things different. Let me try doing things that are a little bit different on purpose. All right, so the next cat that he drew held a cookie. And it's got these small differences. Okay, so he's starting to explore what it means to draw cats and kind of bring in his own kind of influence here. But then phase 3 is intentional deviation from expectations. So the next cats that my son drew were scientist cats doing science, hanging upside down from a harness. Now suddenly, he's come up with a combination of things that was totally unexpected, but it kind of works, right? Well, I think it works, but I'm a proud parent, right? But either way, it's set aside many of the expectations, like doing science hanging upside down, that are very, very intentionally meant to kind of break some of the stereotypes and break away from the previous sorts of things. Now, I like to talk a lot about learning here because, well, we're machine learning scientists. So how does, and some of this actually kind of relates very closely to how we build AI systems. For example, imitation is what we do a lot with. So GANs, for example, anything that involves reconstructive loss is about minimizing the delta between what the system can do and some sort of exemplars. So it's trying to recreate the examples that it's seen. Now, once we figure out how to do that, we can make our discriminators more complicated, right? In addition to recreation loss, we can add additional terms and elements like novelty or some sort of semantic goals along the way. Now, phase 3 is the really kind of tricky part from a creativity standpoint and from a machine learning standpoint, because I don't think we really have very good models or notions of how to intentionally, or how to model this notion of intentional deviation from expectations. Okay, now I've mentioned this word intentionality twice, so let me talk about what I think intentionality means. I think it's the fourth part that we need in creative systems. So what intentionality means, of course, is doing things on purpose, doing things with intent. We can break this down a little bit more. We can say, well, lots of times AI systems are given a goal, draw a cat, draw a banana, whatever it happens to be, right? So we have some sort of particular goal. And the key is that the AI system, an intentional AI system, is able to make choices between alternative, and make the choices based on how they think that those are going to play out with respect to the goal. There's lots of ways of doing planning, doing search. I'm not going to kind of say which way it has to happen, but this notion of selection with intent with regard to final outcomes, I think, is a key sort of thing that we see at least in humans. So level 1 is given a goal and selecting these elements. Level 2 is giving a goal, but then achieving these goals in an unexpected way, right? We're still achieving the goal, but we're going to do some things in a way that kind of surprise you in doing so. And then the third way, the third level of intentionality is actually changing the goals. And this is really kind of interesting because we see people do this all the time. So there was a moment in my son's life when he was much, much younger playing blocks. I managed to capture this where he had started out building a spaceship. He realized that some of the building blocks reminded him of a house, and suddenly started changing everything into a house. So I caught this kind of halfway between spaceship and house here at this point. So children do it, but also adults do it. We've been able to observe this in other creative aspects and be able to kind of like study it in. So intentionality seems to be something that humans do a lot, and is actually kind of something that I think we don't understand as well, especially changing goals in terms of AI systems. Okay, now having kind of thought a little bit about some of the aspects that AI systems or humans even need to exhibit to be considered creative, you might also kind of want to say, well, if it is creative, can we find the creativity? Is there something about a system that we can point to and say, there's where the creativity, this is what is giving me all those features? Okay, so where is the creativity? This is a creative exercise. This is a thought exercise that I like to do a lot when I'm working on a lot of my AI systems. I like to do what's kind of called a creativity audit. I like to think about the sorts of outputs I'm getting from my system and kind of figure out what is responsible for those outputs that I like and I don't like. All right. So, and let me kind of give you some examples of where we might find creativity, or what sorts of modules or aspects of the systems manifest some of these creative properties that we just talked about. Since we're machine learning people here, right, most of us, we can talk about models, right? So creativity might be found in the models. Matter of fact, that might be a good place to find creativity. But we might find it in the model, but it might be because of error, right? So here's an image that I actually think is a very good image. It was meant to be a portrait of me, actually. No, I don't look like that, right? But it's also made a mistake, and it's created two faces here, right? So obviously, there's some things I like about this image are because of mistakes in the model, not fully understanding that humans, let's say, have one head. Okay, but some of the creativity could also be attributed to the ability of AI systems to generalize. So DALL-E, for example, I think is very good at generalizing. It's figured out, that necks on tortoiseshells tend to be positioned in some particular way. And just because it's a giraffe neck and not a tortoise neck doesn't mean it can't kind of figure out where it needs to go. So this is a great example of it being able to meet expectations through generalization. Okay, other places we can find creativity are in the algorithm. Right? So maybe it's the algorithm itself that we want to find the creativity in it. Now, it could be for lots of different reasons why we find it. We can find it in sampling, right? So we like to do a lot of random sampling, sampling from distributions in machine learning systems, right? We like to turn the temperature up on our AI systems. So here's an example of a line that one of my story generators once produced, actually one of my students, Laura Martin, who decided to memorialize this forever in cross-stitch. The horse proves himself as a lawn chair entrepreneur. I'm fairly certain that the word lawn was a low probability random choice on a token distribution. But once it put in the word lawn, it just kind of went with it. Lawn chair. How are we going to reconcile this lawn chair entrepreneur? And as much as I would love to know what this horse is going to do as a lawn chair entrepreneur, I'm pretty sure that the algorithm was not thinking about setting up a story about selling chairs, horses selling chairs, for any particular purpose, right? So we would have wanted to prefer to find creativity in our algorithm through planning and search and realizing that there are reasons why we need horses to sell chairs, for example. That would be great. But we also have to acknowledge that sometimes we find the creativity not in either the model or the algorithm, but all in the problem specification. Matter of fact, this happens a lot when we talk about creative systems that do domain transfer, so style transfer. I love this picture, but I also kind of know that this picture is really great because it had a really great picture of a cat and some art that just happened to transfer onto that image really, really well. Problem specification, creativity can also come through gap infilling or prompt engineering and things like that, where the human is doing a lot of the heavy lifting in terms of the parameters that the AI system then works on. Once we kind of know where the creativity is coming from, we might also want to know to be able to measure that creativity. So how creative is our system? Now, what I'm going to talk about for the next few minutes doesn't come directly from me, but it comes from this great book by Margaret Bowden, The Creative Mind, Myths and Mechanisms. She talks a lot about human creativity, but in a very computational way. And I think a lot of our ideas are become computational. So she talks about three aspects of creativity herself, value, novelty, and surprise. Now, value is the one that I think is the most computational. The idea of value is that there's some sort of user or audience, some consumer of the artifact that gets created by our AI system, and derive some sort of value from it. So if this is art, it could be some sort of intrinsic pleasure. But if it's tool building or architecture or something like that, you might kind of assume that there's kind of some sort of utility to the use of the artifact. The value is typically domain specific, can be multidimensional, but if you can measure utility, for example, then you can actually kind of evaluate this in an automated sort of way. Now, novelty, we've seen before. Don't have to say too much about this. Is how it's different as something from other artifacts. But novelty can actually be, is it novel from anything that the system has generated in the past? It could be novel in terms of the history of all artifacts of the same type, or even kind of novel from the perspective of everything that the observer or the user or the audience has seen in the past. At least these first two you can think of as actually kind of producing some sort of difference or distance function that's very domain dependent, and then you can kind of measure things in an automated sort of fashion. The third one is surprise, and I think this is the most interesting and possibly the most important one, which is that something is creative if it can produce surprise. What does that mean to create surprise? What it means is asking yourself, how likely is it that the creator, whether it's a human or an AI, how likely is it for the creator to have created that output? Is it something that we would have expected from the system, or is it something we would have not expected from the system? So the reason why, I think my son is very creative is not because his pictures of cats are, somehow comparable to what Picasso has ever done, but because when he does something that is new, that's unexpected, that I didn't know he was able to do, it creates this intrinsic pleasure. I think he's been very creative, right? So, and that's proud dad, but I think it's also kind of when we see people that do things that we didn't think that they were able to do, then we think they've broken outside their boundaries. They've done something creative, right? So, but what surprise is all about is not what's in the system, but is what does the audience or the user know and believe about the system, and has it met those expectations, or has it exceeded those expectations? So I'm not sure that surprise can be automated, although without some sort of notion of an AI audience model, and we frankly don't know how to build these things. But I'll kind of point you to some thinking that we've done throughout the various years on trying to build a model of what users think about art or stories. Novelty, value, surprise is all about, I think actually kind of says, what this tells me is that creativity is in the eye of the beholder. No, not that kind of beholder from Dungeons and Dragons, but what I mean is that the artifact is having an impact on an audience, right? So if we want to understand creativity, it's not necessarily just a function of the system itself, but it's a function of the effects of the system on the user. So what is the value to the user? What is the novelty from the perspective of the user? What is the surprise as a function of the user's knowledge about the creativity, the creator? And to me, that suggests that the best and ultimately gold standard way of doing evaluation is going to be human participant evaluations, right? Ask the humans questions, right? So what is the domain-specific success criteria? What is, how novel do they think these things are? What is your level of surprise? But I do also want to mention that in asking questions to human participants, we have to be very, very aware of who we're asking, right? The knowledge about a domain of our users, our audience, our evaluators, or the familiarity with artificial intelligence and computer science can have a big impact in how they evaluate the creativity of the system itself. Think about it this way. I'm much less likely to say I think computer systems are creative just because I know a lot about how these algorithms work, right? Versus someone who is unaware of how AI systems work. And I think the other thing that I want to mention before I go on and talk about other things is that in my experience, here's a warning, right? Never just ask people if they think something is creative. Because I almost guarantee you that if you compare your system against a random baseline and you ask people which one's more creative, people always go with the random, right? Novelty is kind of important, but novelty isn't the whole story, right? And we want to make sure we're not accidentally asking people to rate just novelty or randomness. Now, in addition to understanding how to measure creativity, I'm also very interested in tracking progress towards creativity from the entire scientific, academic, and industry community. And to that end, I've kind of put together a kind of a thought experiment to help me do that. It's called the Lovelace 2.0 test. Now, this is named after Ada Lovelace. Ada Lovelace worked with Charles Babbage to build the analytic engine. Well, they never built it, right? But they did a lot of thinking about it. She was a philosopher, and she was the first person actually on record that I know about who's ever kind of wrote about intelligent creative machines. And so if we're thinking about how to evaluate progress towards artificial creativity, maybe it's a really good idea to name some things after Ada Lovelace. Now, unfortunately, someone beat me to the punch. And there was actually, when I sat down and started thinking about this, I discovered that there's actually someone who already put together something called the Lovelace Test. It's a pretty good test. I should give it homage, and I want to give it homage, right? So Brings, George Velo, and Ferrucci kind of came up with this test of computer creativity, and it kind of works like this. They said, given a human, they develop some sort of AI system, A, right, or an algorithm, A, right? So they make A. That algorithm then outputs some sort of creative artifact, O. You do this multiple times because it shouldn't be kind of just a random creation, but it should actually be kind of something that is capable of reproducing. And then the human or someone who knows more or less what the creator knows about the system kind of looks at the output and says, well, you know what? If I can understand how that output was created, if I understand the output, then it's not creative. It has to be something that actually surprises me. And if I'm not surprised, it's not creative. Now, I think that that's a little bit problematic for the test because I think anyone who really has kind of thought really hard about their computational systems tends not to be very surprised. The answer might be machine learning, but then if you also think about the data and you think really hard about the data and you look at how the data is being processed by algorithms, I think you also kind of find that you're not particularly likely to be surprised by your system. Now, I came into this with a slightly different goal. In 2014, the AI community was challenged with re-envisioning the Turing test. And I was thinking about how the relationships between creativity and intelligence are very tightly bound. So my thinking was to think about how an AI system comprehends a request from a human to perform a task. that requires creativity. So can a computer respond to a request to do something creative, especially if that creative task involves the composition and blending of concepts, like a cat crossed with a spider with an alligator, leg, tail being ridden by a bunny. So again, humans are really good at blending and composition. And getting those compositions and blendings right, I think, kind of require this kind of mental model, shared mental model of the world, right? So the test would then be based around this idea of demonstrating its understanding by being able to create what is requested. And so the Lovelace 2 test, as I ended up calling it, works like this. We have a human. Now, the human is not necessarily the creator of the system anymore, but the human is someone who chooses a set of criteria C, where each of those criteria is expressible in some sort of human language, right? So this means we're not bound by some sort of fixed vocabulary, right? Now, given those criteria, the algorithm has to produce some sort of output. And then the human who came up with the criteria then gets to look at the output and say, do they meet all the criteria C? Yes or no? And if so, that's great. If not, we have kind of an issue. There's one additional aspect, which is we also need a referee. The referee kind of has to look at the criteria and say, okay, yeah, humans can actually do this. We're not asking for the impossible. Okay, so that's kind of the core of the Lovelace 2 test. But to run it, what we do is we do it iteratively. Okay, so we start with one criterion. For example, give me a picture of a penguin. Now, if the system is judged successful, we add new criteria, forcing composition and blending. So give me a penguin on Mars. And we keep doing this. We keep adding criteria and adding criteria until the system fails to pass the criteria, to meet the criteria according to the judge, right? And so the creativity index, we could call it, is basically the number of rounds passed before this judge basically says, no, it's not able to meet all these compositional and blending demands layered on top of each other anymore. One important thing I do want to note about this is that there's no threshold for creativity. We don't say you pass if you pass X number of rounds. What we're just kind of interested in is say, well, how many rounds can you pass? And year to year, do more and more systems pass more and more rounds of these kind of tests. So in that way, we can kind of measure not just the system, but progress of the scientific community in terms of computational creativity itself. Okay, now in 2014, I thought this was a thought experiment, right? So like the Turing test, it was never really meant to be run. It's just a way of kind of like framing the conversation about computational creativity and the relationship between creativity and intelligence, right? But then, of course, like any great thought you have that you think will have lasting implications, a year later, there was this great paper about text to image in which people were asking it to show pictures of stop signs floating in the sky. And then they're blurry kind of red blobs. And there's not much like now that we'd be kind of amazed about it. But at the time, like, it's like, oh shit, things, like maybe we're actually on a really good path here, right? And then our GANs got better, right? Our captioning to image systems got better. And by 2018, they're being built into software that you can go and download. And people were kind of doing all these great things. And I don't think this is necessarily looks like a sheep relaxing in the living room. But in 2020, 2021, right, DALL-E comes out and the offshoots of DALL-E. And now suddenly I'm thinking, I'm seeing images on the internet where it's like, okay, well, maybe the system can do rounds, right? Maybe you can go 2 to 4 rounds on the creativity index before before things kind of start to fall on their face. So let's try it, right? We can actually go get these tools. Matter of fact, a group named by the name of Eleuther AI has put together this VQ GAN plus clip. It's very similar to what DALL-E does, a little bit different, right? But they made a public demo. So, I didn't ask their permission necessarily, but let's just kind of go use their demo and let's just try it. Okay, so let's use the prompts I just suggested. Like, okay, here's a penguin. Give me a penguin. Okay, does it pass? Is this a penguin? Okay, I think it meets a lot of my expectations of what a penguin is. I'm not quite convinced that a penguin has 3 eyes like this, but it looks like it gave a pretty good attempt. So maybe we're okay with this, right? Maybe we say, all right, I think you kind of got it. I think you made a penguin. Okay, penguin on Mars. Okay, clearly Mars here. We have some blobby sorts of things. They're pretty penguin-like, right? So maybe we kind of are satisfied by that. So let's go on, right? Penguin on Mars. What do you wear on Mars? A spacesuit. I actually kind of love this image here. Is this a penguin in a spacesuit? Maybe, maybe not. I don't think it kind of fully understands what a spacesuit is going to look like on a penguin, but let's say it is a spacesuit, right? Let's go on from there. Let's just try. Right? Maybe we're at index 3, right? Let's try 4. What is 4? Penguin on Mars walking in a spacesuit walking a dog. Okay. So there's a blobby thing. It looks kind of like a dog. There's that blobby thing that looks, maybe it's a penguin, maybe it's not in a spacesuit anymore. I don't know. It's starting to kind of lose the plot here, right? It's starting to become pretty uncertain about what's going on. Images are becoming less clear. You know, I might call it here, but let's go on just in case. Walking a robot dog. So we just changed the dog to a robot dog. Okay, so those dogs have mechanical parts. Spacesuit, penguin, maybe we have a penguin, maybe we have a spacesuit here. Maybe it's actually even better than the last one. So one more. We'll try one more, right? Penguin on Mars wearing a spacesuit, walking a dog next to Santa Claus. All right, so clearly we got Santa Claus. Our penguin looks like a banana. We might still have a dog, we might not. It's kind of hard to tell. At this point, we probably kind of shouldn't go on. But I think, you know, this is not a very scientific sort of thing I did. I just kind of threw this together the other evening over the course of an hour or so. But, you know, I think, you know, by some kind of optimistic metrics, we have done, you know, 3 to 4 kind of rounds here, which is not something I would have expected when I started thinking about how to measure progress in terms of computational creativity a few years ago, right? But I think also this is awesome that I could even kind of do this sort of thing and get a number that's, you know, bigger than 0 or bigger than 1. But just to kind of show you like, okay, well, is it reasonable to ask about a penguin in a spacesuit? Okay, so I was able to put this picture together of a penguin in a spacesuit walking a dog on Mars. All right, so I took some classes in high school, art, AP art. I got a 2.0 on the test. That's a failure. I was crushed. I wanted to be an artist. I became an engineer out of spite, basically. So here I am giving this talk. So I guess things worked out. But also, you know, I asked my son again to do the same thing, and this is what he came up with. So these are things that I think humans can do as well. So I think we're on a good track here. But you know, a lot to be said about this. This is not a replicable study, right? When we put this together, I wasn't thinking about all the details to make it replicable. So who are the evaluators? Should we care? Should there be certain judges we do pick and do not pick? How lenient should the evaluators be? I think it was pretty lenient here. Should the evaluation be binary? Yes, no, sorts of things? Or should they be kind of more on a continuum? Should we average creativity indexes across multiple evaluators and doing multiple runs? Do we use the same criteria? Do we need to measure how hard the criteria sets are, or does it not even matter? And do we care about whether our questions are affecting the same spatial area like a robot dog, or whether it's talking about different parts of you know, the screen, because that might actually be easier now. So there's lots of things that we still have to do to kind of make this kind of a real sort of test or a real kind of scientific measurement of creativity. But, you know, again, I think we can kind of look at systems and we can kind of intuitively say, well, I think we're making improvements here, because I could imagine, or I'm actually able to kind of do some basic, simple little tests and say, you know, I wasn't able to do as well last year as I am able to do now. Okay, so I've been talking for a while now. I'm going to leave you with a few little last thoughts, and those are going to kind of go up a level here. I'm going to actually kind of talk about why. Why are we even kind of talking about creativity? I mean, besides the fact that it's totally awesome to build a system that can make art or make a story or a poem or something. I mean, that is what is not awesome about this. I mean, the fact that we get to work on these things, that's great. But I think there's actually some really kind of serious reasons why we wouldn't do this as well, which is that, you know, I think it's really important. We need to understand why is it that creativity is something that comes very natural to humans. It's kind of built into how humans operate, and why it's so hard about computational systems. Why are computers so much different that it's not easy for us to build creative systems. That we have a hard time modeling things like goal changes and expectation and things like that, right? What is it about computers? And if we can answer those sorts of questions, that can inform not just our ability to create creative systems, but it might inform our understanding of how to build just generally intelligent systems overall. Now, from an applied sort of thought side, I think about, our assistive agents that we have out now, not naming names, but there's icons on the screen here. If we want them to be helpful in solving tasks, like help me plan a birthday party, can we have birthday parties with pottery, right? If we're going to make these creative leaps in problem solving, if our AI systems are not able to keep up with us to kind of follow along with these creative leaps, then they're going to be useless as problem solvers, as helpers in problem solving. Right, so we need them to be able to understand our creativity, but also kind of make the same creative leaps we're able to make. And then finally, right, these systems can help us do things that we don't have the skills for. I'm not that good of an artist. I can make art. It's not exactly what I had in mind, but with a little bit of work, I can get these systems to make art that I'm proud and I think is quite amazing. And so can we use it to augment human creative capabilities? Humans are creative, but maybe they don't have the skill. Can we help them augment humans by providing the skills that humans don't have when it comes to expressing the creativity? So lots of great reasons to be studying creativity. If you're working on it already, I think that's great. If you're thinking about working on it, I urge you to do it. It's been some of the most amazing experiences of my life as a scientist. A lot of people to thank, a lot of people whose thinking kind of has informed my own, has gone into this. Many of my students who've come up along the way, as well as my lab in general, kind of helping me spitball sorts of things. My son for providing art. He charged me, but he only charged me $6 for putting his art in there. So anyways, and then Luther AI, which didn't know I was doing this, but I've made lots of use of their tools over the last 48 hours. And I think, they've made it possible for me to kind of push my thinking further as well. So I look forward to the time we'll have to be able to chat and have discussion and conversation. So thank you very much. Yes, made it in one go. Oh, shit. Oh, geez. Oh.